So these are the opening notes that we took on stoichiometry, basically introducing you to the mole and what a mole is. A mole is 6.02 times 10 to the 23rd of anything. 6.02 times 10 to the 23rd is Avogadro's number because he's the person that came up with it. And it's just a counting unit. It's really no different than dozen, but much, much, much bigger. And that's what we want to look at here. We want to look at just how big a mole is so we can wrap our heads around this number. In standard form, it's this number. That's a 6, a 0, and a 2, and 21 more zeros following it. You would read this number as 602,000 billion. So, as you would know, a billion is 9 zeros. So that's a billion. That's a billion. What we have left in front of it is 602,000. So it's 602,000 billion. Scientists don't use quadrillion, quintillions, etc. They just stop at a billion. Now, how big is that number? It's really big. It's so big that you really can't wrap your head around the sheer size of this number. That's why I want to go through and try to help you understand it. Help you understand just how ridiculously large that number is. Let's put it in perspective as something that you may be familiar with, the Big Mac from McDonald's. If you stacked a mole of Big Macs, one on top of the other, just make a tower out of Big Macs, they would stretch to the moon and back 40 trillion times. Like I said, that's a lot. Let's put it into something else that you probably have perspective on, and that is money. What would a mole of pennies be? A mole of pennies would be enough money that if you divided it up amongst all the people in the world, every single person on the planet, everyone could spend $1 million an hour for the rest of their life and never run out of money. Again, a mole is a lot. A mole of sand would cover the state of Texas almost 3 feet deep. But you couldn't do it because there's not even a mole of sand on Earth. But there's more than a mole of silicon dioxide, the molecule that makes up a grain of sand in a single sand castle. And this gets us to the point of why we even use the mole. If you have a mole of normal everyday objects, it's more than you can possibly deal with. It's more than you can possibly imagine. But when we go down to the size of things like atoms and molecules, and we have a mole, then it's not quite much at all. In fact, that's a mole of sucrose, table sugar. That's a mole of copper 2 sulfate right there. That's a mole of sodium chloride, table salt. And that right there is a mole of water. It doesn't even fill up a quarter of that beaker. And that's only a 100 milliliter beaker. That's a small one. We need to use a unit that is immensely large. A huge, huge, huge number. Because atoms and molecules are teeny, teeny, tiny little things. Because the atoms and molecules that make substances up are so small, we need to use a unit that is huge. Now, we talked about converting between moles and particles, and we did a little practice of converting between moles and particles. But I'm not going to go through that in this particular video right here because I already have one from a previous year of teaching. So I'm going to just post that one at the same time as this one. I think it gets a little bit more in detail and goes through the problems a little bit better than what I could do here without being able to write on the screen.